Okay. Hello, everyone. Thank you for joining me today. I'm İlke İleri. I'm a software engineer, and today we're gonna dive into the exciting world of AI agents. Let me share you my screen. Right. So I wanna start with asking you some questions. I can see what you're typing right now on the live stream. I have a second screen. What do you know about agents? Can you tell me, for example, what does AI agents do? Why does AI agents exist, and how they are leveraging AI agents and LangGraph, for example, to unlock their full potential? Hello, everyone. Can you type it? Does anyone have an idea? I'm sorry, there's a technical difficulty. While we are waiting, you can add me on LinkedIn. It's İlke İleri. You can see right here. It is written as it's spelled. Oh, I'm seeing your responses. They are used to make people work. Yes. They do automatic actions. Yes. AI agent is like a smart assistant. I would say this is the closest one. They're like assistants who can help us with our work and do small tasks. They're really correct. Thank you. Have anyone built any agents before? Have you tried it? Is my voice okay now? Guys, I need feedback. Is my voice okay? Okay, so I'm continuing. So let's start from the start again. Good evening, everyone. My name is İlke İleri, and I'm a software engineer. Today, we're going to dive into the exciting world of AI agents, specifically focusing on how LangGraph can help us build intelligent, stateful workflows. This presentation will cover the why, the what, and the how of leveraging AI agents and LangGraph to unlock their full potential. Oops, that's a mistake. Okay, why AI agents now? Let's start with the fundamental question. Traditionally, large languages or LLMs have been excellent at providing one-shot answers. You ask a question, they give you a response. They are by nature stateless, meaning each interaction is independent. If you ever worked with prompt engineering, you know what, like zero shot, one shot, few shots of answers are. Okay. So this is a traditional way. However, when we talk about AI agents, we are moving beyond simple input-output. Agents are designed to think, plan, act, and reflect. This multi-step stateful approach is crucial for Think about like tasks like in-depth research, sophisticated coding projects, or any scenario requiring complex reasoning. We will be doing a hands-on coding challenge when I'm done with the presentation. Traditional LLMs fall short here because they lack the ability to maintain context, use tools efficiently. They can't use tools, or plan multiple steps. They can't do that. Agents fill in this gap by being multi-step, stateful, and capable of tool use, planning, and memory. I'm sure most of you have tried to build an app with ChatGPT, for example, but it fell short because it doesn't have the capabilities. Okay, this brings us to LangGraph. So, what exactly is? Okay, LangGraph is a powerful framework specifically designed to build stateful agent workflows. The key differentiator here is it's in foundation in graphs, not just simple chains. Why graphs? Because graphs enable capabilities essential for complex AI agents, like conditionals, memory state passing, branching, retries, and approvals. Let's go step by step. When we start with conditionals, allowing the agent to make decisions to take different paths based on the current state. I have added an image for that and we will walk through it. Memory state passing. Crucial for maintaining context across multiple steps and ensuring information flows correctly through the workflow. For example, we are talking about let's go on a simple example. For example, you are trying to generate different cover letters for internship applications. You give your CV and you like update. It just forgets your CV. That's annoying as hell. I'm sorry for using that word, but that's really annoying. And we can choose solve this problem with agents. Our next bullet is branching, retries, and approvals. These features provide robustness and flexibility, allowing more sophisticated and resilient agent behaviors. Imagine an agent that can retry a failed action or even seek human. That's really cool. Yes. When we come to the graph I talked about, let's go step by step. To illustrate how LangGraph works, let's look at a practical example of this workflow. At its core, we initialize a state graph. Let me see. I can see. Yes, state graph. We define it here. This is to initialize a state graph object, which will manage the state of our agent. Okay. At its core, I'm sorry, I messed up. Then we define nodes, which represent distinct actions or decisions within our workflow. In this example, we have a researcher node, right? A chart generator node, right? And a call tool node. These are like building blocks of agent's brain, step by step, like we always do in programming. In next, we define edges, which dictate the transitions between the nodes. LangGraph really shines here with conditional edges. Instead of fixed paths, we can route the flow based on specific conditions, which is really cool. For instance, from the researcher node, a router decides to take the next step. It could continue the chart generator, call tool, or even the process. I think there's a problem with the stream. Let's wait for a couple seconds. Can you hear me? The camera only, so you can hear me. And you can see the slides. Okay, that's not a problem then. Uh, yes, we set an entry point for the graph execution. In this case, the researcher node, once defined, we compile the workflow and our intelligent agent is ready to go. Okay, now I can close off my camera. Yes. Okay. This visual representation highlights the dynamic and interconnected nature of LangGraph workflows. Are we clear on this? Okay, I'm going to the next slide. I feel like a lecturer. Okay. Let's zoom out a little bit and look at the general architecture of an agent workflow. An agent's journey typically begins with user input. Oh, didn't my slide change? Can someone confirm? Okay, change now. So, the user input kicks off a series of steps: planning, tool use, reasoning, action, reflection, and response. Let's start with the planning part. Planning step is the one the agent strategizes how to address the input. Then we go to tool use. It identifies and utilizes appropriate tools like external APIs or databases to gather information or perform actions. Reasoning: the agent processes the gathered information and draws conclusions, which is really important, and we don't get this with one-shot answers in LLMs. In action, this is the part where it gets tricky and really differs from a traditional LLM. It performs the necessary actions based on its reasoning. I think that's really cool. On reflection, crucially, the agent reflects on its actions and outcomes, learning and refining its approach. In the response, finally, it delivers a coherent response to the user. I'm just going to the technical side right now. After this, once we have the idea of agents and how they work, we will start on coding. Okay, let's go back to this one. In LangGraph, each one of these steps can become a dedicated node. We can have LLM nodes, tool nodes, conditional nodes, even human approval nodes earlier. For the LLM nodes, they are for reasoning and generating text. Tool nodes are for interacting with external systems. Conditional nodes for decision making and flow control. And human approval nodes are for allowing human oversight and intervention when necessary. You can think of it like reinforcement learning. And the overall flow involves the LLM agent interacting with an environment by taking actions and receiving observations, rewards. It uses a tree search mechanism. If you ever dealt with data science, you've heard about this tree search mechanism to find the best node or path. All of this is informed by a constantly evolving memory and evaluated through self-reflection based on. This interconnected system allows for truly intelligent and adaptable behavior. There's a fun fact. Let's share it with the audience. AI agents are getting social, being trained on understand emotions, facial expressions, and even tone of voice, allowing for more natural human-agent interaction. That's really scary and cool at the same time. I don't know. I'm so confused. Okay, 1 second, please. Yes, slide 6. What does LangGraph let you? LangGraph provides three core capabilities that empower us to build these sophisticated agents. Uh, we can define as a state for the first step. As we saw earlier, agents are stateful. LangGraph allows you to define a shared state that persists through the workflow. This state, represented as a type tick in Python, can include things like messages, the current task, and the tools used. This is vital for maintaining context and its memory. The second thing LangGraph lets you is to connect nodes to mutated. It's really going out of hand with this one. The nodes in your graph are not isolated, are designed to interact with and modify this shared state. Each action taken by a node updates the state, providing continuous flow of information and context. On the third bullet, the LangGraph lets you control flow with conditionals. This is where the intelligent part really comes in. As discussed, LangGraph enables dynamic routing based on the state. You can define functions and analyze the current state and decide which node to execute next, making your workflows highly adaptable. As we can see here, I'm checking the chat. Chat, is this true? I feel like a streamer. I guess I'm a streamer right now. Okay. Let's follow along with the slide 7. Conditional logic in action. Here we have a simple Python function called shouldContinue. This function takes the research state as an input. It checks if the iteration count has reached max iterations. If it has, the function returns summarize, indicating the workflow should transition into a summarization step. Otherwise, it returns continue, meaning the research process should proceed. The beauty of this is that LangGraph routes the graph based on this decision, not hard-coded paths. This dynamic routing is fundamental to building adaptable and robust agent behaviors. This is really what's separating from agents from simple traditional LLMs, actually. While AI agents are powerful, there are times when human input is essential. This is where human in the loops capabilities come in. Sometimes AI truly needs your input to ensure accuracy, compliance, or simply to make critical decisions. LangGraph integrates human approval steps directly into your workflow. For example, a human approval node could print a summary, and the prompt for user input is approve, yes or no. This is incredibly valuable in use cases where high stakes are involved, such as legal reviews. Ensuring legal documents meet specific criteria. Fact-checking, verifying information before it's published or acted upon. Medical decisioning, providing an extra layer of scrutiny in the sensitive medical context. Taking it a step further, LangGraph also enables sophisticated multi-agent collaboration. It never stops. Imagine a scenario where a complex task is broken down into subtasks, each handled by a specialized agent. This is where a master agent or a supervisor agent comes to play. The supervisor agent acts like an orchestrator, deciding which specialized agent should handle a particular part of the task. For instance, if the task involves writing code, it routes the code agent. If it requires information gathering, it directs it to a research agent. Okay, can you hear me? Okay, tamam. So I'm continuing. Okay. This distributed approach allows for highly efficient and modular workflows, leveraging the strengths of different agents for specific functionalities. So, how do all these pieces fit together to create a functional AI agent? First, LangGraph is graph plus state engine. What it means is at the heart of LangGraph, providing the foundational graph structure and the state engine that manages the flow and memory of your agent, LangChain tool abstraction complements LangGraph by offering robust abstractions. This means easy integration with various external tools like search engines, databases, or APIs, which are essential for agents with the real world. Think of this as the agent's arms and legs. The third step. The large language model serves as the brain of your agent. It provides the intelligence for reasoning, understanding, and generating responses. And when it comes to you, you are the supervisor, you are the debugger. And finally, you play a critical role as a supervisor and a debugger. You design the workflows, monitor their performance, and debug any issues that arise, guiding agent to optimal performance. Uh, I want to ask you guys, is everything going okay? Is everything going smoothly? If you don't understand the point, I can go back to it. Or am I speaking too fast or too slow? Or am I speaking too fast or too slow? Okay, great. So I'm continuing. Let me shut this off. Okay. When moving AI agents from development to production, there are several crucial considerations. Uh, Async and concurrency. For efficiency, you'll want to run multiple agent nodes concurrently, especially when tasks are independent, such as fetching data from multiple APIs or performing parallel analysis. This significantly speeds up complex workflows. Second, checkpoints and monitoring. It is vital to save the agent's internal state after each step. This enables you to pause and resume workflows, inspect the state for debugging, and effectively monitor performance. 3. Prompt safety. Preventing hallucinations, unsafe generations, or prompt links is paramount. Ensuring the LLM behaves as intended, adheres to safety guidelines is a continuous effort. I think this is usually overlooked, but this is so crucial. There are so many injections about prompt safety, and there are so many startups just like vibe coding, and they have so many security violations. So just be careful. Last but not least, retry and fallback logic. Robust agents need to handle failures gracefully. I think this is one of the coolest features because if they fail, they get up and they try again. So should you. Implement mechanisms for retrying failed steps automatically and consider falling back to alternative tools or models. If a failure persists, this ensures the agent can recover from errors and continue its task. Okay, let's see our use case. We are suggesting an affordable summer vacation cities with safety, weather, and cost details. This is the part we are going to be seeing coding, but before we start coding, I want to share the idea that wanted to share with you so we can search, analyze, decide, and summarize it better. So, step by step workflow overview. The agent begins by reading the user's input, like suggest affordable summer vacation cities with safety, weather, and cost details. It then uses a language model to extract key requirements, such as when the user wants to travel, their budget, what specific information they want to know about cities, how many city recommendations to provide, any geographic preferences the user might have. Once the user's requirements are understood, the next step is to select candidate cities. Based on the parsed requirements, the agent picks a list of candidate cities. This might come from a curated list of affordable summer destinations. It then limits the number of cities to match the user's request, ensuring a focused and relevant output. These are the part that is prompted. I will show you in the code. With the candidate cities identified, the gathered data about each city. For each selected city, the agent collects detailed information from various external APIs or services. This data typically includes weather data, safety index, local events, cost of living data. After gathering the data, a crucial step is to reflect on data quality. The agent reviews the collected data, checking for completeness and errors. It uses the LLM again to decide if it has enough good data to proceed or if should retry gathering or missing data. This self-correction mechanism ensures data integrity. Following the reflection, if the LLM determines that the data is insufficient, perhaps due to many errors or missing information, the agent will repeat data gathering if needed. It retries the data collection step up to a maximum number of attempts to avoid infinite loops. The resilience is vital for robust agent performance. Once the agent is satisfied with the data quality, it moves on to analyze and rank cities. It analyzes the data and calculates a composite score for each city. This score considers how affordable the city is relative to the user's budget, how good the weather is for summer travel. In this example, you can do whatever you want. How safe the city is, how many interesting events are happening. Based on the scores, it generates readable recommendations. Each city is good or less good choice. The final step in this workflow is to generate the final report. The agent prepares a structured report for the user, typically as nicely formatted HTML page or JSON output. I'm sorry, front-end developers. This report lists the cities ranked by their composite score, includes detailed information about costs, weather, safety, and events, and clearly explains their recommendations. So now I will switch to the coding part. Let me stop my screen sharing for a minute. And one second, please. Yes. I can't see my pie charm. No. Let me 1 second, please. There it is. Okay. Okay. So I can see my screen now on the live stream. I'm starting the coding part. This is an autonomous travel agent being built using LangGraph that recommends affordable summer vacation destinations, as we talked. It uses AI reasoning, multiple data sources, and self reflection to provide comprehensive travel recommendations. So, I will start by explaining every single state, every single function. So, let's start. Let's start with the important dependencies. Guys, it's so hot here. I'm just gonna turn on my fan. If there's any disruptions with the audio, please just tell me, okay? I hope it's gonna be fine. Okay. Just tell me if there's any distractions with the voice. So, let's start with the dependencies. We are importing OS, random, datetime, typing. Let's just go. OS is for access environment variables for API keys. Random is for generating mock data for demonstrations. Datetime is for timestamp reports. And typing is for it hints for better the code screen bigger. Sure. I hope it's better now. And I can I think. It's not up in the font. Can you see now? Let me go in the I'm looking for the font to make it bigger. I'm trying to find the font size, guys. I'm sorry for the delay. Yes, appearance. Yes, increase font size. I hope it's better now. The stream is falling from behind, so sorry for the wait. So I think this is good, so I'm continuing. Yes. Uh, I like to add fallbacks to my code. For example, I had a problem with the tool executor right here because I was importing a tool executor from LangGraph. Do we need to zoom in more? Okay. It should get bigger now. Yes. I like to introduce these fallbacks. This handles a potential import issue. It wasn't potential, it happened. By providing a fallback tool executor class. The agent can work even if the pre-built tool executor isn't available. The issue I had here was I was importing the LangGraph pre-built tool executor, but it didn't support the, what do you call it? I forgot the word both in Turkish and English. Version control, yeah. It didn't get updated with the version. So we can solve these problems with like these fallback manual implementations. So we imported LangChain. We imported Grok because I used a Grok API for this agent because I don't have a ChatGPT Pro and I don't have an OpenAI API. So Grok is free. If you want to try it, it's working good. So let's go to data models and state definition. I'm sorry. Yes, let's start with class seeded data. Why this matters? This use Pydantic for data validation and structure. It ensures consistent data format across the system, like we specified here. And optional fields allow for missing data, as we see here. If there's a missing data, since this is optional, it'll go by. And makes the core code more maintainable and less error prone, which is so important when we are working with a big code block like this. Like we have, how many? We have almost 1,000 line of code. I'm sorry, I'm so bad at explaining code. You have to stick with me. It will get easier, I promise. For this agent state, like we talked earlier, this is the shared state that flows through all agent steps. LangGraph uses this to maintain context and data across the entire workflow. Think of it as the agent's memory and workspace. Like we specified before, we will have the messages, user requests, parse requirements. We will be parsing some data, candidate cities, city data, current step, errors, like we discussed. All the steps. That's why I kept the presentation that long, so it's better to understand. So let's see mock tool implementations. Why mock data? Demonstrates the concept without requiring real API keys. I use this mock data here because I didn't have any APIs connecting to these like weather stuff. I could have found one, but just to tell and show, this is enough. Allows testing and development without external dependencies. In production, we can replace this with a real API. So this is more computationally easy to run for me. So Uh, let's get to the safety index. Uh, this is a smart feature. This intentionally simulates API failures to test the agent's error handling and reflection capabilities. Real world APIs fail sometimes, most of the time, so the agent needs to handle this gracefully, like we discussed earlier. Yes, of course, we will send the code. You can implement it as you wish. Okay. We will get the local events, cost of living. These are the features that will be handled gracefully. The travel agent. Okay. I'm sorry, I'm lost right now. I forgot what to say. It works on my machine. So I'm just cracking jokes. So let me see. Oops. That's what I'm looking for. Yes. It was right in front of my eye. I couldn't see it. That's what happens when you get too excited. So let's just pretend it didn't happen. Okay. The eight direct parameters, environment variable, and helpful error messages for setup. For example, we don't always hate errors. When we have value errors, it can help us plenty. Uh, I have my API key entered from the terminal because I shouldn't share it with you guys. I'm sorry, I can't. Let's come to the LLM part. As I said earlier, I am using Grok and I am using Llama 370B for this model. This is relatively faster, and we kept the temperature at 0.1 because we don't want it to hallucinate. And we kept the max token at 1,000. It's a low token count, but it gets the job done because we don't need tons of response. Okay. When we run this, when the Grok API connection is successful, we get redirected to building the graph. So this workflow of design represents a cognitive step that a human travel agent would perform. This is the intelligent part. We are adding the nodes for each cognitive step. We will parse requirements, select candidate cities, gather city data, reflect and validate, analyze and rank, generate report. Uh, yes, we are doing this with in connection with the LLM, so it works for us. So we have all this information from the build graph part, okay? But how are we gonna use them, right? We need to parse requirements. Remember I told you we were working with the LLM and that part, so how we talk to LLMs? We prompt. Why this works, the LLM converts natural language into structured requirements. This is crucial for making the agent understand exactly what the user wants. For example, in this prompt, we asked for the LLM to analyze the user's request, as we mentioned here before on the upper places. It will be extracting the following requirements: travel season, timing, budget level, affordable, what daily budget, required information types, geographic preferences, number of cities recommend. And we will be getting the parsing the LLM response. For example, the season is summer. The budget level is affordable. The max daily cost is $70. Required info is weather, safety, events, and cost. Number of cities is 5. We can alter this whatever you want. You can list 100 cities. And the geographic scope is international, whatever in the world. Okay, thank you. You can give me negative feedback as well. I will be sending you the code. Don't worry. Do you want me to share it with you right now? I can share it with you right now. Let's share it. I'm sorry. 1 second, please. Let's do this interactive, right? If you are all on your PCs, let me share the project with you. Export. File. Yes. Hassan, I'm sharing the file with you. Can you please share it on the group so everyone can see simultaneously? I will wait for it for a couple seconds. So just text me when you are ready and we will go step by step and work this out together, okay? I think that's way more fun. Okay, I'm proceeding. Our next step is gathering the seeded data here. Okay. So each tool call is wrapped in try-catch blocks. Errors are logged but don't crash the entire process. The agent can make recommendations even with partial data. This is why, because we remember in the start, we did these optional, right? Because we did these optional, we can go with partial data, which is awesome. Yes. So this function will be gathering data for each city using available tools. Okay. These are the catch blocks. Gather safety data. Gather events data. Gather cost data. And at the end, when this all cycle is done, it will return state. And it will convert it to a HTML page, which we will see in the end of this code explanation. Okay. Reflect and validate. This is one of the most crucial parts of this whole system. The agent reflects on its own performance and decides whether to continue or retry. This is inspired by human problem solving, where we assess our progress and adjust our approach. Of course, we are doing this with a prompt. Okay. There's no new messages. I'm seeing my own screen at the iPad, and I think you texted, but you're not. So, how do we do this? We enter prompt, analyze the data collection results. City is processed. This will take the city data from the state we just returned, right? Errors encountered. From here, current iteration. Remember the current iteration? Like we had steps. Where was it? Yes. I just saw it. Yeah, current step. So it's all tied together. It always amazes me all the time. God, I love my job. After these are gathered, we have questions to consider. Do I have sufficient data to make good recommendations? Are there critical gaps that need addressing? Should I retry failed data with available data? And the last is the data quality acceptable for the user's needs? I would say to make good work, you should be really proficient in Python programming for these parts and prompt engineering for the whole shebang. Okay. And when we get the response, we get decision. And we analyze the data completeness, and we store them in city data errors. If the data isn't enough, if it's not sufficient, we retry. But if it's enough, we finalize to prevent infinite loops, which is a nightmare. When I was coding this, it happened to me. It was so bad. Oh, I have a Turkish comment here. That's all. I usually don't do this. Are there any Turkish people? I don't think so, but I just wanted to ask. I don't think so. Even if the LLM gave the decision of retry, we should check the iteration steps and then we retry or finalize. If we exceeded our steps, we finalize. I'm sorry. Okay. Yes. We come to analyze and rank. Why do we have this? This is called weighted scoring. Different factors have different importance levels. Not everything is black and white. Cost is most important, let's say 40%, and for 40% for budget travel. Safety is crucial, let's call it 30%, and weather matters as well. Of course, you want to have a nice summer vacation, it's 20%, and events are nice to have, they're like 10% important. In this function, we are calculating those factors and bringing them together to make decisions, right? Let's come to advanced features. After all these calculations, we generate certain recommendations. Generate city recommendation, generate report. By the way, did you guys run the code? Have you tried to run the code? If you don't have PyCharm, you can run it on Google Colab as well. It's faster. We can try. So let's come to the advanced features that we have here. Okay. Uh, this part of the code is for graceful degradation. Degradation, yes. If HTML generation fails, the agent falls back to a simple text report. For example, when you open a website and your connection is bad, you see a basic HTML file. This is what it does. The user always gets something useful, okay? Uh, this is the HTML report. I'm not going to explain this. This is basic HTML. This is not related, actually. Let's see our iteration control. Let me see. This is still the report. HTML is tiring. Okay. No, I can't find it. 1 second, please. Okay. Yes, here. Okay. Why do we have this? As I said earlier, this prevents infinite loops. The agent won't get stuck retrying forever. After 3 attempts, it proceeds with whatever data it has. For the HTML output, let's see. Let's not look for it. Yes, here. The agent generates a styled HTML report that looks professional and easy to read. Yes, this is all HTML, guys. And we will show the end result in a second. So, before I show you the end result, I want to talk about why this architecture works. The first step it's modular. Each step is a separate function that can be tested and modified independently. The second is state management. The shared state ensures all steps have access to the same data and can build upon each other's work. Error resilience. Multiple layers of error handling ensure the agent provides useful output even when the things go wrong, which we all know things always go wrong. Extensibility. New tools, scoring criteria, or processing steps can be easily added to the workflow. Last but not least, transparency. The agent tracks its reasoning process, errors, and decisions, making it. What can we use these agents for? For example, real-world applications. This pattern can be adapted for research agents, content creation, data analysis, customer service. The key insight is that complex tasks being broken down into discrete, manageable steps with checkpoints for quality control and error recovery. This architecture demonstrates how AI agents can be more than just chatbots. They can be autonomous systems that reason, plan, execute, and self-correct to accomplish complex, multi-step tasks. So, do you guys want to see the end result? One second. Yes. This is our agent's output. Cute little HTML, affordable summer travel destinations. We had this analysis today, and we prompted our budget to be $70 a day, right? And we gave 7 cities to be analyzed. So let's go through what cities got recommended. in our mock data. Top recommendation is Prague from Czech Republic, but it is expensive, right? But accommodation is $40, food is $20 approximately. Transport is $8, activities are $25. Okay. Weather information, it has it all. The condition is pleasant. I feel like a pilot right now. The temperature is 24 centigrade degrees and humidity is 60%, rainfall 80 millimeters. Safety details. Safety index is 85 out of 100, which is good. And the crime level is low and the true safety is good. I would say this is a good destination for a girls trip, right? Local events and recommendation. We have a sentence here generated by the LLM itself. Let's see what it says. Prague, Czech Republic offers excellent value for summer travel with $93 a day average daily costs. The weather is 24 centigrade degrees, pleasant, making it comfortable for sightseeing with a safety index of 87%. It is reasonably safe for tourists. The city features 3 notable summer events and activities. Overall score 51 out of 100 based on cost effectiveness, weather, safety, and cultural offerings. Our second city is Lisbon, Portugal. Overall score is 46. I want to score 46. This is why we need human input, guys. Daily total, oh, I can see why, is $110. We have the cost breakdown, the weather information, again, warm and sunny, humidity, rainfall. Safety index is 82%, which is better. Let's see what our LLM thinks for us. Lisbon, Portugal offers excellent value for summer travel with $110 a day average daily costs. The weather is 28 degrees and sunny, making it comfortable for sightseeing with a safety index of 82%. It's reasonably safe for tourists. You can see the prompt acting on right now. The sentence is different. Remember the state got returned and the returned information was in the prompt, so it fits right in like a puzzle. 3 is Warsaw, Poland. I thought Warsaw was a relatively cheaper city. Oh, summer music festival and outdoor cinema. Bangkok, Thailand, if you wanna try some Eastern Asia. But let's see, it's hot and humid. Crime level is moderate. I think there's some things going out there. Budapest, Hungary. For example, there's a whole section for data collection issues. We couldn't find saved data for Budapest, but we still proceeded, right? But we told our user that we don't have enough data for Budapest. So, what are agents summarized for us? This report was generated through autonomous agent reasoning with the following steps. 1. Requirement parsing and goal decomposition. 2. Candidate city selection based on affordability. Yes. Multi-tool data gathering, weather, safety, events, costs, reflection, and quality validation. Multi-criteria analysis and ranking, and last but not least, structured report generation. I think you will recognize these steps by our presentation, right? Let me share it with you real quick. Where was it? Yes, step-by-step workflow, like we discussed before. Search, analyze, decide, and summarize. This is how AI agent works. Let me show you my face again, so you remember my face when you are adding me from LinkedIn. Yes. Thank you for listening to me today. It was longer than an hour. This was my longest presentation today. I think I didn't bore you. I hope I didn't bore you. I hope it was fun. I am just checking your comments. Do you have any questions? Please just scan the QR code to add me on LinkedIn. You can email me, you can text me on LinkedIn. I will accept anyone's connections. And go build your own AI agent. I think you will find out something smarter than I did and more impressive. So I'm looking for questions right now. You think it didn't find any good cities? What are you saying? What is a good city for you? You find it for me. I want to try. Thank you. Let me see the comments from my. I'm sorry, I'm looking for the link to see it on my computer. My iPad is. The LinkedIn is on the screen right now, actually. I'm still waiting for the good city recommendations, guys. How can you say my agent didn't find good city recommendations? Yeah, everything will be shared on the group, guys. I can't hear you, Hassan. Okay. Everything, the code, the presentation, everything will be shared on the group, guys. Oh, the best score. Yeah, you're right on that. Yeah. Nice to meet you as well. Thank you. Thank you for taking the time. I hope you enjoyed it. I hope you got a grasp of what agents are, how they work, and why they exist. This was our first line of the presentation. I hope I fulfilled your expectations. Okay, that's all from me. Thank you for listening to me today. I will come to Beirut someday. I get it recommended quite often. Okay, guys, thank you. Do we have hearts here? No, we don't. Okay, thank you all. Can you like and subscribe? I always